Here's a quick note on how to go from a test schematic, test bench or whatever you say, to test a cell. Right now it's a D flip-flop, to testing the layout version of that cell. And the most important part when going from testing the schematic to testing the layout is to ensure that you're testing both of those under the exact same conditions, as exact as you can make them without going too crazy. Because otherwise you can't, you make sure your schematic works fine, and then if you test your layout under different conditions, it's basically not valid to compare your measurements, and it's not consistent. So here we go. First we're going to run the simulation on here, but before we do the simulation, we always run DRC. DRC, zero errors. That's what we want to see. I'm also going to say that's it. Alright, so we'll run Spice on this. My shortcut is F4. Run the simulation. It runs the simulation. That's wonderful. Clock, D, Q, so on. So this is the simulation that was set up. What we want to notice is we'll look at our netlist. This is made up of a bunch of subcircuits. So subcircuit, 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 subcircuit. There's our D flip-flop. This is all the subcircuits. Now this is our top level cell. That's what it says. Here's our instance of our D flip-flop. That's our unit under test or device under test. You will see DUT quite often. It just means device under test. All of these other inverters, their whole reason for being there is to drive the D and the clock bar inputs of our D flip-flop, and also to load the Q and the Q bar inputs or outputs of that D flip-flop. In that Spice code node, we have a ground to connect it to 0, a 5-volt power supply, our clock, pulse source, and our VN pulse source, and including our C5.text and the simulation. This UIC is actually not necessary because we're not making an oscillator, and it can find a DC solution for time step 0. Also, .options post, it's commented out, so we don't even need to put it in there because it's commented out. I'm going to Control I on this. Select Control I, multi-line text. I'm going to anchor it to the left just because it makes the text a little bit nicer to read, yeah? I think you would agree. I'm going to take off UIC and .option post because it's not necessary and superfluous. So we go over to our layout view, okay? And what we want to do is we want to just drop down just our D flip-flop. It's the layout. We can show it if we wish, or if we don't wish, and so on, okay? We'll go back to our schematic. Look how I named these. We have RD, CK, CKB, Q, and Q bar. Those are the pins, or those are the node names, net names in Spice that we are most interested in. I don't care about what this name is. I don't care about what this name is, or this name, or well, that's Q, or any of the names on the output of these inverters. We'll just let electric name those itself. Go back to our layout. Actually, go back to our schematic. We'll run Spice again. F4. The only reason we're running Spice is to get this netlist. Scroll down, so the Spice code stuff, the Spice code stuff is in here. That was in that node, but we also want, I'm not doing this selection very nice, so we also want this, all of this, except for the .end, because that closes our simulation, and the D flip-flop itself. Actually, I'm going to include this in there because I want to make it easy for me to copy paste. So I'm going to say Control C, go back over to our schematic, or the layout version. We're going to drop down a Spice code node, which is over here, Spice code. drop it some random place, zoom in, because that text is teeny. Control I on that, and we want to make sure we have multi-line text. Control V. If we look in here, we have everything. There, we say OK. There it is. Control I. I'll just make this left because it's easier to read. And so on. OK. That's great. Okay. So clock, clock bar, RD, Q, Q bar, instance of D flip-flop. This is actually important to us. We're going to go back and take a look at our pins on here. So VDD, we're going to leave VDD. They're considered global nodes. I really don't like that convention. I'm going to put a wire on clock. Oops. And D and clock bar. The only reason I'm doing this is so I can name these nodes. So select, it's white, draw something out, we have make a little noise. Okay. So this name was what? Q? Q? Yeah. Q bar is here. The colors are a little hard to see. Go back to this side and we have CK is what I called clock. If you remember, that's what the clock was called, that node, CK. CKB, wasn't me that named it, it was actually Aaron. That's RD. This one is going to be called, I forget, what's that hooked to? Clock bar. CKB. Is that all our pins? CK, CKB, D input, Q and Q bar. And don't draw that wire. Control 9, zoom out. Let's make this text a lot bigger. A lot bigger. 10. Why is it not going bigger? 9. Okay. Alright, doesn't really matter. Here we go. Ready? F5. DRC. Let's go to our message window. 0 errors, 0 warnings. This is what we need. I'm going to also run NCC. Have that set up. Uh-oh. Clock and D. Clock and D. Oh. Because we have exports on our schematic. We don't really need exports on our schematic. So this one is called C node D. This one is called node COK. CC, go back to our layout. DRC, NCC. Exports, we're going to ignore that one for now because we're just doing spice. A whole bunch of inverters over here. No inverters in the layout because we didn't put them. They're only in spice. This is okay. And then all of these are pretty much our wires that it's not finding in the layout. That's all right. Actually, run spice. See what happens. Pin miscount. Okay. GND in out VDD, GND in latch bar out VDD, clock. Do you see how we have ground and VDD connections now in all of these? Well, I believe we have exports in the layout version. If I do NCC of this, exports match. Exports match. Here's our layout. The node name, BDD. If we look, okay. Let's do that. That's our VDD grant node. GND. Try that. Exports. Okay. 4. D flip flop. Ground bar. This is okay. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. What? Why doesn't it like? D flip flop. XDFF2. Oops. XDFF2. You see XDFF2? XDFF2 is our old D flip-flop from the schematic version. We kept it in there just so we could get those node names and remember them. We need to delete that because otherwise we effectively have 2 D flip-flops. That's not what we want. Delete. Okay. Ground in and out. Ground in and out. Where's that error again? Xfin 20 0 0. So we have this and this. Okay. Okay, so we have a definition of an inverter. This one now has GND and VDD. Because this is the layout, it has those node names. In and out. So, you know this whole .global thing that showed up? .global VDD and GND? This is not here anymore. Why? Well, because this is on a chip, we have to actually wire up the power and the ground, or the power supply terminals. Is there a setting for us to ignore this? NCC, let's go to Spice. Use cell parameters, units, subcircuit. I think we're okay. Create subcircuit ports. We can actually extract all of that. Okay. 4 again. You see what the problem is? These schematic versions and these are the layout versions. Our inverter has a bunch of extra resistors and capacitors. They're very small, 6 ohm resistors and femtofarad or attofarad capacitors. 102 attofarads, it's really small. But we have these GND and VDD connections. Well, you know what? We can just hand edit this if we wish. That's what I'm going to do. They're all the same. This is one solution to this issue. And I'll go back up to here. You can watch me. Might want to go faster than this. Does it work? Close all these, man. It does. See, what's going on is we have all these inverters down here. They're only there for our testing. But the inverters that we put in there are being extracted from the layout, which when we do the layout we have these ground and VDD pins. This global stuff is just a royal pain. My advice is don't do global nodes. Don't do global power and ground nodes because it causes problems. It causes a lot of problems. And that's how we do it. So we're going to plot clock, RD, and Q. Those are our pins. Takes a minute to do that. Works a little different. I'm going to say, oops, save plot settings because I don't want to do these plots again. Close Spice. Run this again, F4. You see what's going on with the plot screen? What's going on is it plots it, and then as the axis expands when we're generating simulation data, it actually has to redraw the screen. There's a whole lot of data on that screen, and if you do it like this, it takes a whole lot of time to print, and most of your time is spent redrawing the screen instead of actually simulating. We can do that, change that in our preferences in control panel, and under waveforms, it's not waveforms, it's operation fast, I forget. Operation netlist. Here it is. Marching waveforms right here. See how that's checked? That means it updates the plot on the fly. I'm going to say OK. It will save that preference. F4 again. What? Alright, that wasn't the setting. That's annoying. Marching waveforms. Marching waveforms. There it is. Oh, I didn't save it. So we do that. See how it's not starred? Okay. If I say run, runs, it's simulating. Almost done. This is great. And then it goes plot. Although marching waveforms is not a setting that you can persist between sessions of LT-Spice. So another way around that is to save your plot settings, but save your plot settings with a different name than testbench.plt. And then when it's done, you can say open plot settings and open up your fancy plot settings. Make your measurements. You're good to go. And so on. I think that's the end. This is kind of a long video, but we got into some issues, fixed those issues from the Spice side, and now that we've codified pretty much all of our testing stuff here, we updated that, our special inverters, and we didn't have to do an inverter layout of all those inverters and hook them up, which is absolutely wonderful. Thanks for watching.